Hey there, welcome back to the channel. So, in the previous video, uh, I was debugging stuff, and just take a look at this. So, if I make it and I run this with, let's simply run this. See, it's working. The code is finally working, and let me show you how it's working. So, git log, and if I show you uh, what I changed in, well, I did not change the previous video, but take a look at this. Just a single line change and it works. It's a major bug fix. Yep. We were debugging for the past 2 days and this is it. This was the error. It's done, it's working. If I show you the score in like a detailed manner, so take a look at this. My code, so this is the throughput as compared to the libc. So libc has a throughput of this, but I assume libc is doing some kind of like like atomic, the safety related to threads, what it's called, mutexing or atomics, those kind of stuff. I think it's handling that. That's why my throughput is higher. So it's like, see, 100%, mostly it's 100%, but utilization is bad. So I figured out why the utilization is bad. So let's take a look at this trace file. So this is the trace file 9. So if I show you this, it has a lot of reallocs. So let me show you. So this is A. A stands for alloc, which means allocate the zeroth index. Well, not zeroth index, but it's a serial number. So serial number zero block to 500 and of a size of 512 bytes. So the zeroth block has 512 bytes. It's just indexing. And when we are to free, we just give it what index, what size, like what is the serial number of the block that we want to free up. And there's another thing which is R. R means realloc. Well, let's say that the block is already allocated, but we want to change the size of the block that is allocated. Let's say, in example, let's say you might have used vector in C++ or a normal list in Python. So what it does is that its size changes dynamically as user tries to push elements inside it. So it needs to reallocate stuff. So what vector does is that you might be knowing like vector has two kind of things. It has a length and it has capacity. So whenever the capacity and length become equal and we want to push another thing, uh, the vector asks for twice as more space and then just moves the length pointer to accommodate that stuff. So that's what realloc is about. It's just reallocating space. So what if we are asking for lesser space? Let's say our new process doesn't need that much memory. Let's say over here, let's assume A. A asks the process 0 asks for 512 bytes. Realloc tells that the zeroth block, which is this one, it earlier had 512 bytes, but it needs to change to 640. That's increasing. That's fair, you know. And then we increase this again, increase this again, increase this again, increase. Well, it keeps on increasing, I assume. Yep, it keeps on increasing. But eventually, I think it asks for lesser block. It might not be this trace file, but okay. So if our process asks for a lesser number of bytes, we don't need to allocate new stuff. My current, let me show you. My current reallocator, like the realloc function looks like this. It is just directly calling mymalloc. It is copying like what size it has and what kind of size it has. If it's less, then we just keep it the same, and then we copy it, and then we free the pointer. So irrespective of whatever the thing is, we are simply directly calling mymalloc, even if the size is smaller. That should not be happening. If the size that we are asking for is lesser than the current size, we should just split the block, right? Instead of calling mymalloc and traversing the entire free list. So that's what we are going to do. So let's get into it. Uh, so okay, let's go. Let's write our new. So today's work is we are going to write a new realloc function. So let's go ahead. Void pointer my size t size, and over here. So first of all, let's get the size of current block. So let's get the current block over here. Block is equal to block header pointer. We cast that pointer over here. Yep, cool. And then size t block size is equal to block size. Nice. Um, let's also get its footer. Sorry, footer block is equal to footer block pointer cal pointer. So our pointer points to the starting of the space, not at the starting of the entire block. So we will write over here pointer plus we will move it by block size only. So cool. So now we have values for the block. So that's cool. Now we will check if the size is smaller. So if what we can say is so if size is smaller than block size, that means we can allocate the space over there itself. So now we have to also add a condition, which is should I do it like that? Okay, let's make it a single statement. So block size minus size is greater than zero, and let's call it difference. So size to difference is equal to block size minus size if difference is greater than zero, and then difference is at least if difference happens to be greater than zero and difference is at least greater than or equal to header plus footer, then we can split the block. Else if difference is greater than zero and then so yeah. So now we have to write the splitting logic. So let's do it. Let's write first all the conditions that we have. So difference is zero, difference greater than zero is covered over here. If it's greater, that means a greater block is allocated. So let's get the values for this. So bool left free is equal to what was the function again? Left free block or something. Yeah, it takes in a void pointer. Yeah, and we directly do. Yeah, got it, got it. Okay. Left free block. Send in the pointer. Yep, that is it. Right free, right free block pointer. Yep, nice. So here we will check if left and right. So if it's greater, we have to also make sure. Hmm. Space utilization, right? This is going to be a bit of hassle. Realloc function has a uh, lot of ways to perform something. Let's not get into this right now. Let's first write a simple logic for now. So difference is greater than zero, and difference is greater than header plus footer, which means yeah, which means we can do it. This is pretty simple. We can just return pointer again because even though the number of bytes has been reduced, it is still, you can say, it's we still don't have a lot of space to allocate header plus footer. This condition is going to be less, but it's fine. Let's keep it. So if difference is greater than zero and difference is greater than or equal to header plus footer, so if it's greater than or equal to header plus footer, that means we can split the block. So let's reallocate. So the size that we want, should I align the size right now? Yeah, well, I should have aligned the size first of all. Yeah. Okay, okay. So size 3 aligned size is equal to align size tool, and then we have mentioned side over here. So this is good. Yup, this is cool. And okay, let's do it. It's aligned and it's greater. So let's just go ahead. Okay, so it's aligned. We don't have to do anything to the header. Our allocated block stays the same. We just need to change the we just need to change some stuff. So difference, which means let me do an example. So let's say our previous block was of um what should we take? 80 bytes. So this was earlier of 80 bytes, and now the new size comes in and it is just 40. So we reduce 40 from this, and then we move this over here, and then we are left with 40. So difference is the total difference, which is the new block. So this difference value is uh, the new stuff that we have. So we have to create a new footer. So okay. So okay. Let's do it. So new block header. New block header is header block. Not char pointer. We'll just directly convert it. Footer block is new block. Footer is equal to footer block pointer will move ahead by align size. That's what we want. So we move ahead by align size. So that's what we are going to create our stuff at. Sorry, sorry. So okay, and then we will create a new header block at this point. So that I will also write useful space. So size t useful space that we have over here is difference minus header minus footer. So this is the useful space that we have. So let's change this value. So new blocks, I should have written it over here. Yeah, new block header size is equal to align size now, and new blocks footer size is also aligned size. Hmm. These are the silly mistakes that I make. So block size, yeah, perfect. I removed the what you can say, the one from it, like getting the actual size instead of just like I did not consider the LSP inside this. That's what I did basically. So that's cool. Yep, align size. This is cool. So this is align size, and I still need to like make it um your R1. Hmm. So now the split block logic. So useful space is this one. Let's create a pointer over there. So split block. Let's call it split block. So header block pointer split block header is equal to header block pointer char pointer. We'll move footer. So new block footer plus footer itself. So we have footer, we move by footer, and then we are over here. That's cool. This is the new block header. Yeah. And then for the footer block, we have split block footer. Oh, I messed up. So footer block pointer, char pointer. Let's call it split block header. Split block header plus useful space. Should I write? Yeah. Let's call it new ph instead of all of this complex stuff. BH and BF block footer. New new header, new footer. Yeah, this is simple, right? Yeah, this is simple. New header, new footer, useful space, and split header and split footer. The same thing over here. So new footer and split header. So this is cool. Smaller names, better to read, easier to read. Yeah, okay. So we have the values for this. Let's change the values. So the split block needs to go inside the new free block, right? Yeah, this needs to be added into the new free block. Okay, let's do it. So first, let's change values for this. So for the allocated block, that's fine, but just in case, new header next should be null. Just making sure. I know it would already be null, but just making sure. So We are over here. Um, then just a minute. Hey there, back again. So yeah, if I go into split it, then we need to add it into the free list. So this is fine. Split header, split footer. This is cool. Let's change its values. So split header size is now equal to the useful space. Cool. And the same thing. So space, just the footer is useful space. Cool. Sorry. Nice. And now you need to add it into the free list. What was the code for the free list? I forgot. So where did it go? Yeah, this is it, right? New blocks next should point to free pointer. I think we can write this in a better way, but okay. How about we just copy this for now? So if you have new header, split thing, yeah, that. This is fine. So the split header's next value should be free pointer. No question in that. And then the new blocks. The next value has been changed. Yeah, if free pointer is not equal to null, yep, perfect. Next block hasn't been changed much. Yeah, if free pointer is not equal to null, then free pointer's previous value should be our split block, split header, and then so this points to this. Yeah, so current blocks. So split blocks previous pointer is equal to null, and then free pointer is now split header, right? So split headers next will be free pointer itself because the split block will be added to the start of the free list. Hmm. And then the next value will point to this, previous value will be null. If free pointer is not equal to null, which means the original first block, then its previous value will be split header and free pointer. Yeah, this is perfect. So boom, we have added our block dig into the free this. So this is cool. This is working. Yeah, let's commit this. So this is fine. This is working. Let's create a new feature branch. Let's call it realloc itself. Yeah, yeah, yeah. Let's remove the realloc entirely. We don't need it anymore. Let's keep it for now. Yep, this is fine. This is perfect. That's what we added. Git add. Let's create a new branch. Git branch. We are in main. Git branch. What should we call it? Realloc. Git checkout realloc. Diff. Oh, what is happening? Git diff. Yeah, it remains. And then git add. We are inside realloc. Yeah, git commit dash m. Let's call it um realloc. It was related to realloc. So realloc handles block size reduction. You can say so. Okay. So my git branch is this. Git log looks like this. So that's cool. And now my commit is done. So now git push origin. I want this branch, which is realloc. So let's see. And here it goes. Resolving deltas, create a pull request. This is fine. And let's check. Or yeah, we have a realloc branch. One commit ahead, which was realloc handles the block size reduction. 44 lines added, 0 removed. So okay, this is working. So half an hour, 28 minutes in, that's cool. Oh, okay, so yeah, let's let's get right into it. So again, let's continue. Let's remove this. So now we will be covering the left and right free. So there is a lot of stuff over here that you need to consider, right? Because realloc. Okay, okay. Let me tell you. Let me show you what I'm talking about. Nobody really watches this part, but if you're watching this, as I've said, uh, thanks for watching. You know. So okay. Sorry. Yeah. So let's say this was our block, which is allocated. So this is sorry. So this was a allocated block. I'll write that. Yeah. So this is allocated block, and if we were to reduce this, that is fine. But if we have to increase this, what we were doing originally is that we were directly calling my malloc, and it used to look inside traverse filters. But the thing is that what it should do instead is that it should check if the adjacent blocks, right, uh, right block and left block. It should check if the left block and right block are free. So let's say both of them happen to be free. So what should we do? Do we need both of them? So we should first check if both of them are free, then like first of all, if both of them are free, or I should now that I think I should consider one thing which is difference greater than or equal to zero. Let me do that simple change. I will forget. Let me do that simple change right now. So this is what I'm talking about. I did not consider this. So difference, even if it's zero, that's fine. We still move. We still do this because then it will go inside this. Yeah. Let's also so so now we know that we are coming to this conclusion. Command Shift K. Yeah. We are getting over here. The only reason we are getting over here is that this block isn't enough. So do we need to merge only the left block with this, or do we need to add the right block too? But what if the left block is allocated and the right block is free? Then we definitely need to merge both this one. If the right block is allocated and left is free, we need to merge these two. And if both of them are allocated, let's cover that logic first. So if both of them are allocated, we'll directly be calling um, uh, my malloc. Let's cover that logic first. If that is, let's go from the easy one to the hard one. So yeah, we go over here. So if left free and right free, but negative ones. So if both of them are allocated, then what do we do? When we know that it is not enough, then we will just call uh, my malloc. So yeah, void pointer new pointer is equal to my malloc. You can see what was it? Align size. Yeah. Let's copy the same logic. If new pointer is equal to null, we just return null. So that's cool. And then yeah, we create a copy size, which is the size, yeah, dereference stuff. If size is less than copy size, If the new block is smaller than the old one, we have to stop copying early so that we don't write off at the end of the new block. Just give me a minute. Back again. So, yeah, so what it's doing is that we shouldn't overwrite the stuff. So it's taking the smaller one. So, yeah, that we will also do that. So, we can see, what should we say? The align size and the current block size, right? Hmm. The current block size is over here. It did not go over there and did not go over there. Here, here and block size. Yeah, yeah, cool, cool, cool. So let's call it smaller size. So size t, smaller size is equal to studmin. There is no studmin operation, right? So smaller size. Uh, from this, we actually know that the block is going to be greater, right? So we don't need to do all of these things. We just need to copy the stuff. Yeah, let's do it. So the pointer we get is this, and then we will copy that. So mem copy, it's over here. Mem copy, and to what? How many bytes? Yeah, yeah. So mem copy the new pointer, whatever that starts from new pointer, to the pointer with a size of line size. So that's cool. The new pointer that we get. Oh, I shouldn't copy the new pointer itself, right? Yeah, yeah, cool, cool, cool. We shouldn't be asking for new pointer itself. We should be asking for header plus footer, and let's set that up. So new pointer, I should be calling it new pointer. So header block, new pointer header is equal to header block pointer, new pointer itself, and footer block pointer, new pointer footer, new pointer plus header plus we asked for a line size. So we are at footer now. So we will copy new pointer align size over there. Sorry. So yeah, we will not copy new pointer, but we'll copy space. Let's call it space. Yeah. Uh, yeah. Let's do it over here. So void pointer space. Let's call it new pointer space is equal to void pointer char pointer new pointer plus just the header. So that's cool. And then we have over here new pointer space. So we will copy all of this stuff into the new pointer space. It starts from pointer with a size of line size. So that's cool. It shouldn't be a line size. It should be block size. This was the size that I got from the pointer. So yeah, this is block size. Cool. And then we free our current pointer. So free pointer takes a pointer. Yep, that's cool. So the new pointer header, we need to change the values for them. New pointer header is aligned size or one. Block size does handle that, right? Yeah, still. Pointer is replaced with our aligned size or one. So that's cool. So we copy the stuff. We'll also set the values to um, null. Find edge replace with our sorry, replace with edge previous. Yep, cool. So mem copy, we are copying this value, pointer block size. Have I covered everything? So we get new pointer. So earlier we had a block size, but we needed to increase that. We need to increase it by align, increase it to align size. So we ask my malloc for align size plus header plus footer. Hmm. And the new pointer, if it's null, we return null. We get the new pointer headers and footers, and then we set their sizes perfectly. We set the next and previous values to null because it's an allocated block. We are just reallocating stuff. And the void pointer, new pointer is, since we need to copy every single thing, the new pointer speed starts from header plus header. And then we copy that stuff, and then I guess, yeah, only my free is remaining. So um, my free pointer, you can say, right? So my free pointer, and then we return new pointer. Return new pointer is. Yep, cool. So this is it. So this is also in a decent condition, right? So this is cool, right? If it's the only single block. Okay, so both of them are allocated as is handled perfectly. So now we need to check like if the left block is allocated. There are a lot of things. Should we make this a short video, 44 minutes? Yeah, I think we should make a short video. Yeah, I guess let's end this over here. So git diff looks like this. Git status. Yeah, nothing much. Difference greater than or equal to zero, greater than or equal to zero. That's fine. And what was the previous commit? Realloc handles blocks as reduction. Yeah, cool. Yeah, let's commit this and end the video. So git add, git commit. Um, what should we call it? What should we call it? Uh, sorry, git commit. So realloc handles size increase when adjacent blocks are allocated. When both adjacent blocks are allocated. Realloc handles size increase. What is the approach of what is the opposition like antonym for reduction? No, no, I want antonym. Size expansion. Should we call it expansion? Reduction. Yeah, let's call it expansion. Realloc handles size expansion when both adjacent blocks are allocated. Yep. Git push. Oh yeah, I have to set a upstream. Set upstream origin. Realloc. Yep. Sorry. Realloc handles size expansion. So this is cool. So I guess let's end the video right over here. This shouldn't work, right? This will give us an error. So yeah, let's end the video right now. So thanks for watching this video. I'm Aditya Bachorni and I'm an engineer for fun. Bye.